I'm starting out in Trackunit Marketplace, where right now we have 163 ecosystem applications, including new IrisX blueprints. Each blueprint is designed to support a specific business problem using real machine data, without you having to build everything from scratch. Here you can see the initially available blueprints. They cover different business problems, resulting in operational efficiency gains, revenue potential, and so on. What I want to focus on now is how OEMs and product teams can actually use real-world machine data to improve how they design equipment. This is the data-driven product design blueprint. The idea here is simple. Instead of relying on assumptions about how machines are used, you can now see how they actually perform in the field. So things like load, duty cycles, temperature, utilization, all of that is captured and turned into something usable for engineering and product decisions. And if you don't have access yet, sign up to become an IrisX user, and then you can simply request it directly here on the marketplace. So onboarding to these use cases becomes very lightweight, no long implementation cycle, just controlled access to value. So let's jump into it. Now, instead of navigating through dashboards or building queries manually, I can simply ask a question in natural language. So I'll ask, how does engine load, torque, drive fuel consumption across the fleet, and which equipment's cohorts are outliers? What IrisX is doing is translating that question into data analysis across the entire fleet, combining telematics data and determining signals, aggregations, and so on. Then, within a couple of seconds, I get a full response. Not just a chart, but a structured answer. What we see here at the top is an executive summary indicating that torque is a strong driver of fuel consumption and that it increases significantly at higher load levels. Right here, I can also see that impact visually in the graph. What's then interesting is when we go beyond the average, because now IrisX breaks this down by equipment type. So instead of one fleet-wide answer, I can actually see how different machine cohorts behave. For example, some equipment types show maybe a stronger correlation between torque and fuel consumption, meaning their behavior is likely more closely tied to load, whereas others show a much weaker correlation as well, which means these are the machines where fuel consumption is driven by something else, not just torque. So in a matter of seconds, we have gone from a simple question to actually a statistical analysis, visual validation, and a written summary, all without a single line of code. Let me ask another question, just to show a different angle. How does fleet utilization, operating hours per asset, vary by region, and are there seasonal patterns? Again, just a simple question in natural language, and within a couple of seconds, we get a structured answer back. Why have I asked that question? I can now spot immediately differences across regions, which is the really important perspective here, because it tells us that machines are not used the same way globally. Usage patterns are heavily influenced by where the equipment operates. And if I look over time, I can also see how those patterns evolve, whether usage is stable, seasonal, or maybe fluctuating again across the regions. And exactly identifying those insights is what matters when it comes to the product team's work. Because understanding regional usage pattern helps to ensure that machines are designed for how they are actually used, not just for an assumed average. Now, one more thing I wanted to quickly show, because it's not just about what you can analyze, but also where you can access it. So everything you've just seen, all of this analysis can of course be done directly within IrisX Analytics. But what's really powerful is that we can also bring these capabilities into environments that users are already working in. For example, Trackunit Manager. So instead of asking users to switch tools, learn a new interface, or move data around, we bring the analytics to where the decisions are actually being made. So quick sneak peek from my end, and shout out to our AI product and engineering teams. Through Trackunit's MCP server, we can embed these analytics capabilities directly into Manager or even elsewhere, meaning you can ask the same kind of questions and get the same level of insights right there. And that matters, because again, it lowers the barrier to actually using data. It's not just for data specialists anymore. It becomes accessible to product managers, service teams, operations, anyone who really needs those answers. So instead of analytics being a separate activity, it can become part of everyday workflows. So using AI to make advanced data capabilities easy to access, easy to use, and available where they create the most value. So if this is interesting to you, hey, I encourage you explore the Trackunit marketplace and request access to the blueprints that are relevant for your business. For instance, the data-driven R&D blueprint that we've just seen.